All right, welcome back to graphing exponential functions. At the beginning of the year, we did a whole section on transformations. We learned how to transform a parabola, a cubic, an absolute value, and a quadratic. I think that's about all of them. So today we are going to bring back transformations, and we are going to transform exponential functions now. So my parent function is y equals a times b to the x. And then in general form, it's a times b to the x minus h plus k. So we have to remember, what in the world do a, h, and k do to a graph? Let's see if we can remember from first semester. I am going to use y equals 2 to the x for all my examples. So every single one of my b's is going to be a 2 for illustration purposes only. Okay, so if a is greater than 1, so we're saying like a equals 3. If I have y equals 3 times 2 to the x, that 3 right there, if you have a number bigger than 1 in front of your function, you're supposed to remember that that makes your function stretch. So this one is going to stretch by a factor of 3. And then if we had a number between 0 and 1, that's how you read that. A is somewhere between 0 and 1. So let's say a is a third. If I have y equals 1/3 times 2 to the x. So when your a value is a third, we have to remember that that is going to make it compress. So stretch means that it pulls it up, and then compress means that it flattens it down. And then finally, if a is any kind of a negative number, so if I have y equals negative 1 times 2 to the x, or maybe it would just read y equals negative 2 to the x, or it could be a combo. It could be like negative 1/8 times 2 to the x. But anytime you have a negative there, you have to remember that that is going to make your function reflect. And so if it reflects, so over here, it looked like this. If it's going to reflect, then it looks, it's going to cross like right there and then go down. And so this is what a reflecting function would look like. So it takes it and it just flips it over the x-axis. All right. So now we have to see, what does h do? So if we had y equals 2 to the x plus 3. All right, so you have to remember, if you are hanging out with your ex, that they lie to you. It always does the opposite. And it does the opposite mainly because there is this minus there. And that minus minus means that it actually went left 3 units. What if I have y equals 2 to the x minus 7? So 7 just is the number that's right there. And that means your function actually went to the right 7. And then k is the number off to the side. The number off to the side moved your function up and down. So vertical means up and down. And that is also going to be where your asymptote lies. So if I have y to 2 to the x, I haven't used a 5 yet, plus 5, That plus 5 right there means it's going to go up 5 units. And then if I have y to the 2 to the x minus 10, that means it is going to go down 10 units. All right, so we have a couple of combos. So the number out in front, so that's my A. You're hanging out with your X, that's the H. And then that one is the K. All right, so the 2, it's bigger than 1, so that means it's going to stretch by a factor of 2. X plus 6, it's always the opposite, so that means it's going to move left 6. And then minus 8 means that it's going to go down 8 units. All right, over here, we have 2 A's going on. So I have the negative and I have the 1/8. X minus 1, that's my H. And then the plus 7 is my K. So this negative and this 1/8 are doing 2 things. The negative is making it reflect. The 1/8 means it is going to compress by 1/8. X minus 1 means that it is going to go right 1. And plus 7 means it is going to go up 7 units. So that is how you take a function, look at all the parts, and know how it is going to transform or move around from your original parent function. All right, we're going to sketch a couple of graphs, and we are going to check this on Desmos, and this is really just heavy calculator work. All right, so I want to graph this. When I want to graph this, I'm wondering, do I always just go -2 to 2? You can, but here's the better idea. You look at whatever your exponent is, and you ask yourself, what would make this add up to 0? Or you just take the opposite. So the opposite of -4 is +4. So you're going to make the opposite your middle number here. And you're going to go bigger, bigger, smaller, smaller. Quite frankly, I just plugged this into my calculator because that is the easiest way to do it. I'm going to use a lot of parentheses. Clear. I'm going to use a lot of parentheses times 2. I'm going to hit my caret key to get my exponent. And now I am going to do my math right here. So 2 minus 4 is -2. So I have an exponent of -2. And then I'm just going to go plus 1. And my calculator knows that after that, it is out of the exponent. And so I get 1.75. Let's see if I can make all this be on the screen. Kind of some reflections, sorry. All right. So now I'm going to move on to the 3. The only thing that's changed is my exponent. 3 minus 4 is -1. On mine, I can hit my up keypad and I can arrow over. And so just change that 2 to a 1. And that y value is now 2.5. And I'm going to keep going with this. 4 minus 4 is 0, so I'm going to arrow up and arrow over. I'm going to have to hit the delete key on mine to get rid of the negative now. Change that to a 0 and hit your enter key. And I get 4. When x is 5, 5 minus 4 is 1. So I'm going to go change my exponent to 1 now. Get 7. Arrow up and arrow over. 6 minus 4 is 2. And I get a 13. All right, so before I graph it, the other thing that I do is I identify my asymptote. So up here on the notes that's off the screen, it says that your K is also your asymptote. I find that super helpful to draw in so that my graph should approach that line but will never, ever, ever cross it. I have an asymptote at y equals 1. All right, go plot some points. 2, 1.75 is just about there. 3, 2.5. 4, 4. 5, 7. And 6, 13 just goes off the graph. So I can see that it's kind of starting to turn. If you're having a hard time visualizing that, you can always plug more numbers in. So if you wanted to, like I ended up plugging 0 into my calculator when I did my notes earlier, and I got 1.2. So at 0, I'm at 1.2. So I'm just above that line. And so my graph is going to curve and then just kind of go hug that line and go right next to it. And it's going to get really flat and it will never, ever cross it. So if you had to graph something and I had to grade it, I would look at this. Does your graph approach your asymptote but never cross it? All right, so up here, that is approaching infinity. And over here, it is approaching 1. All right, so your type. You read a graph from left to right, and it is going up, and the increasing ones are called growth. Your domain, I can choose any value of x that I want to. I can use negative numbers. I can put negative 10 in, and I just know that I'm going to get like 1.0001 or something like that. So my domain goes negative infinity to infinity because I can plug anything I want in for x. Your range are your y's, so they will always be, well, if it's a growth, it'll be greater than your asymptote. And so when you write this in interval notation, I would say it goes 1 to infinity. The transformations are probably the most important part of this section. There's only going to be one graph. So identify your A, H, and K. And so there's my A, there's my H, and there's my K. 3 is my A, and that made it stretch by a factor of 3. That x minus 4 means that it moved to the right 4. And then that plus 1 at the end means that it moved up 1 unit. So the transformations are by far the most important part of this section. Number 6, you're gonna need to look at my completed notes later. But I can see that this is my B. I don't have any number out in front, so I don't have any kind of stretch or compress. That's my H, and that is my K right there. And I do see that B equals 1/3, and I do know that I will get a decay kind of function. And so that plus 5 means it is going to go to the left 5, and that minus 2 means that it's going to go down 2 units. So you should have an asymptote right there where it approaches it, but it will never cross. And let's see, it should end up looking something like that. We've done several transformations, and let's see if I can do these in 30 seconds. If I'm going to reflect, that means that A is going to be -1. Compress means that that's an A, and left means that that is my H function. Using the parent, y equals A times B to the x minus H plus K. So in place of A, I'm plugging in -1/3.